Okay, the central limit theorem is what we're dealing with here, and it says for all samples of the same size n, when n is greater than 30, the sampling distribution of x bar can be approximated by a normal distribution with a mean mu and a standard deviation of sigma divided by the square root of n. This is still going to be a little bit different than when we just did the regular normal distribution. Okay, what does it say? The population with any distribution has a mean, mu, and a standard deviation. Simple random samples of all size n are selected from the population. And then you've got that you should have the population normally distributed, or n should be greater than 30. So that's kind of the information that you mainly need for this section. And here, what I want us to do, they tell us we have a mean of 75.0 beats per minute and a standard deviation, and they want. If we select one female randomly, find the probability that the pulse rate is less than 82 beats per minute. Well, first thing I want to do is I want to pull up StatCrunch, because I'm going to use StatCrunch. Okay. Sometimes you have to sign in and you pull it up. Okay, I'm already signed in. If not, I would use the same credentials that I would use to sign in to my math lab. And I want to pull open StatCrunch. Okay, so I'm going to use StatCrunch. So I'm going to kind of put it over here. I want to put this over this way. And I want to be able to see both of them. So we're going to kind of do our screens. Of course, those of you that are on a Windows-based machine, it's easier to get your screens to work right. Okay, so we're doing the normal distribution again, is all we're doing. So we're going to go to Stat, Calculator, and go to Normal. First thing we need to pick up out of here is the mean, and our mean is 75. So put that in. Then we want the standard deviation, that is 12.5. Okay, then read the question. If one female is randomly selected, find the probability that her pulse rate is less than 82 beats per minute. So less than, we've got less than equal to is what you're using here, and compute. Okay, we get an answer. And that's 0.7123 when I round it to 4 decimal places. The 6 rounds that 2 up. Okay, but now we have to divide it by the square root of 25. The standard deviation is divided by the square root of 25 with a mean less than 82 beats. Well, depending on where you want to put this, you can maybe rearrange this a little bit. But what has to happen is if you know the standard deviation, it's here, and then you're going to divide it by the square root of 25. There's no way for me just to put square root of 25 here. I know the square root of 25 is 5, so I'm just going to plug in the 5 for now, and I'll show you how you can do it later. And we've got 0.9974. Okay, it says, why can the normal distribution be used in part B even though the sample size does not exceed 30? It says that the sample is what, or the population is what, normally distributed. Since the original population has a normal distribution, the distribution of sample means is a normal distribution for any sample size. Okay.